Hello everyone. How are you doing? This is Manikandan Selvam. This is my video, and we are from SuperIndex DB, the fastest database server on the planet. Now we are going to talk about, in this video we are going to talk about the basic concepts of database server. The industry experienced people, they know like what is database server, how database server works, and what are all the basic components of database server, and how to use the database server for our web applications or the non-web applications. How do we use it? And everybody knows it. And this video will be useful for the newcomers who want to understand what is database server in the easiest way, or even for the experts, it will give you a different dimension, because this is also going to talk about SuperIndex DB. This is a different DB database structure. A database, and with the different data structure we have, that's called SuperIndex data structure. Please just continue watching this video. I'll go one by one in this. So first, what we are going to talk about is um, okay. What we are going to talk about is the basic database server basic concepts. Okay, what is that? Like usually, database server will have only data. It has everything related to data. Say tables, data. That's it. There is no meaning, semantics in that. Say, for example, Aadhaar database in India, or SSN database in United States. It just has a data, say SSN table, SSN number, SSN name, SSN address, and SSN start date and SSN end date. That's it. That's a table. If you come to India, and other number, other person, and other address, and other start date, other end date, important details. It's a data. So these data, how the end user can utilize it? So end user is a person who utilizes the data, or who requires the data, or who needs the data. Say, for example, if you are going to any pilgrims like Tirupati, they just check the Aadhaar number. So they are the end user, and they want to check the Aadhaar database with the Aadhaar number, whether this person is a eligible person in India to go everywhere and to go to the pilgrims and everything. So they are the end user, and they need to access the database. So they are the end user, and these end users may be web-based end users who surf internet and connect to the database and get some do some operations like fetch the record or insert a record or anything. So in between this client, right? There are non-web based clients. Non-web based clients are like batch processing. Say automatically the things will be running. The ration system is connected to the Aadhaar system in India, or the SSN system is connected to the defense and visa-based USCIS system, right? So when they connect it, right? So they need a connection, so they will have their batch operations and everything. That's a non-web based operations, right? Okay, we forget. We'll talk more about that in a different video. Like, but basically we have a client who access or who need to access it. So when we come to client and the database, the relationship, right? Client directly cannot write a query to the database because of various reasons. One is that he needs to know the syntax of the database server, or what format he will get the data, and how he will access the data in the pagination, or no, somebody need to align it, and somebody need to process the data in a proper way. That's why we have a concept called application servers and the web servers. Application server usually connect to the database, and it fetches, and whatever the operations, database operations you need to do, application server does it. And it just sometimes it connects to web server, or sometimes without a web server it may provide the data to the end user. Say for example, in a web concept, in the internet concept, like an end user will type something in the web page, right? He will type, this is my other number, this is my other name, and something like that. And whatever he types, right, that record will be converted or will be moved to the application server, and the application server will move all this information to the database server, and it fetches the records from the database server. Once it fetches the record from database server, it just revert that answer or whatever the connections it needs. It will go back to the client. So that's why we have the roles in the concept of web, internet, or non-internet, right? Database server will be there. It must be there. Application servers and the web servers must be there, and we should have a clients. Those systems must be there. So these are all the important things which you need to know. Okay, we said database multiple times, right? The database is a collection of tables. We say collection. There is a relationship between the tables. So how that will be connected? But if you want to know the traditional systems, right? Go back to traditional system, 18th century, 19th century. The people used to keep the database in the files, in the records. So they arrange it, they index it properly. If you go to library, right, they will index, right. The book starts from letter B. You go to the row B, right. In that row B, you go to the index B and next letter or something like that. So arrange it properly. That is a database, the record keeping tool. That's a database. But coming to the RDBMS, relational database management system in the software, the tables are connected. Say, for example, Aadhaar table in India, it must connect with PAN table, right? PAN number. Say in other table, I will have a corresponding PAN number, and that PAN number I will just again connect to the second database that's called PAN database. So why I need to connect these two tables? See, I want to know whether the person has PAN number as well as the other number, whether he can integrate to the banks, right? For example, if you have account in XYZ bank or HDFC bank or ICICI bank, they are connected to this database, this table, and they just map it and see whether this is mapped properly. It is not only for that. Relational database is not only for that. Say, employee table, we will write it without a salary information, and sometimes we will write a salary information, or we can have a separate table for salary, and only the connection between the employee table and the salary table is the employee ID. So we can connect, say employee ID is 678 and the person name is XYZ, and the person's salary, if you want to know the same employee ID, I need to specify it in the salary table with the salary details. So that's called the relationship between the databases. So that's why the RDBMS, relational database management system concepts, has come, right? So how the relations usually, in practically, if you see the softwares, right, in the web-based softwares or the database softwares, it will be like this. That there will be multiple tables and multiple columns, and each column will connect it. Say column in the table is something like, say other table. If you take an example, other number, other name, other address, other start date, other end date, the employee number, employee table, sorry, employee name, employee address, something like that. So that's a column. So the columns will be connected in the tables, right? So the sample table, if you want to see, like, usually how the sample table will be. So this is the picture, like this sample table, right? It has student ID, last name of the student, the initial of the student, age of that particular student, and what program he is studying. So it is all connected. See, there is rows, there is a column. Column is the information, common information like student ID or age. Row is the, number of entities, number of person in this class, number of person in the other table, something like that. So this is the basic concept of database, uh, with the relations what we are talking about. Okay, but when we come to the operations, right, database operations in the database server, we usually, we need to create the database before starting everything. I need to create the database. The database is a bunch of tables, a collection of tables, collection of views. There are many things are there. Views concept, I'll talk it in the different video. Even I was in the previous video I was mentioning about it. So we will talk more about that. So here we need to create the database. So that's why we say before starting the table or before start using the table, before creating the table, we must create the database, right? So after creating the database, after then we need to create the table. Once we create a table, multiple tables, right? Or we can play with the database, like we can insert a record, we can update the record, we can delete the record, or even fetch. We can search the record, right? So that's a basic concept. Okay, now we will connect all our elements in the real-time world. Like, okay, this is a SuperIndex DB's model, but usually if you go to any databases, this will be the pretty much equal. Like application server, web server, they need to connect to the database server. That connection mechanism is called in Java world we say JDBC, Java Database Connectivity. In the .NET world we call ODBC, Open Database Connectivity. So this connectivity is required to connect from application to the database server. So these connections, how it will happen? It needs a medium, right? So it uses the driver. So all the individual database servers in the industry, they have a separate drivers. So SuperIndex also, we have a SuperIndex driver. So you need to download the SuperIndex driver and you need to connect that driver from your application or web server and you just connect to the database using a JDBC, Java Database Connectivity. Or if even we support ODBC like from .NET, whatever the concepts we have. This is the way we need to write an automatic program so that the client, right? You see here, the client, he will just connect it to the web server or application server via the internet pages or mobile. See, in the mobile, you will be typing something. Okay, this is the other number. I want to know what is the answer. You just type it and send it to the web server, and the web server and application server will process, and they will connect, use the SuperIndex driver, and they will connect to the database server, and the database server will serve the database back to you, and that information you will fetch it into the clients. So that is a usual process, right? So when we come to know the clients, right, or the end user, right? So they must to connect it in the program. That is what we are saying. But sometimes that end user directly they want to talk to the database server for various reasons. Say for example, developer, he want to know what data is there in the particular table, or a database administrator, you want to know some processing, okay, whether the database is happening properly, whether how many records are there, what is the size of the table, what is the size of the database. If you want to know, if you want to connect it to the database server, right, they must need a client, right? So that client, if you come to the Windows world, Windows operating system world, that could be a UI client, the UI based. You can open a client, you can log into the database, and you can do whatever the operations you want. Or sometimes the Windows command prompt, you can open a Windows command prompt and you can just type, okay, I want to connect to this database. Yes. I want to know how many records are there. I want to insert a record. I want to delete a record. I want to select a record. So for that, we need to have a client. So SuperIndex DB also, we have two different type of clients. One is the Windows command prompt client. That client can be installed in, it's a bat file. You can install it in the Windows, and directly you can connect to the database server and just see. See, actually, these clients are not. I mean, these clients are not useful when you go to the online production system. This is I mean, before going to the production, if somebody want to analyze or somebody want to use it, even after going to the production, somebody want to analyze directly, without contacting anybody to the database server, they can use it. And we have a Windows UI client also. SuperIndex also have SuperIndex client, Windows UI. So there are several medium to talk to the database server. As I said, we have SuperIndexer driver, SuperIndex client. Windows command prompt, and Windows UI based client. So this is a basic concept of a database server, like how the database server is integrated to application and web servers and the client, and how this is happening. If you see SuperIndex DB, I will talk about that later. We have driver, we have client, and server. It will be there in the cloud. Talk about that. Okay. As I already mentioned, what is a driver? The driver, SuperIndex database driver, is a computer program that implements a protocol, JDBC or ODBC for a SuperIndex database connection. That's it. Okay. So how usually the drivers the people will be using? This is a sample Java program. You see that I just have a URL, the JDBC SuperIndex colon SuperIndex server name, and the port name is, for example, 1000, and the database name. And if you want to create true, you need to create it. If you don't want to create it, without a creation, database creation, you can run it. You need to specify the user and the password. You need to specify everything. And this connection, I'm just connecting it through the driver manager. How I'm just connecting it? I'm just connecting it, using the predefined package, java.sql package that is imported here. Import java.sql, and after importing, so we can just use the driver manager method here. It's a public method, and that method I'm just connecting it. After connecting it, I go into the insert, like create table T2, something like that. So how is the command based SuperIndex client will be? It will be like this. It's called SuperIndex client. We call it a SI client. You can just install a bat in your Windows machine. You can just click it and it will come like this, and you can type whatever the way you want to connect to the database server, like create table, insert a record, or select a record, drop SuperIndex, create SuperIndex, like whatever you want, you can play with here. So this is a basic stuff, like we say in SuperIndex DB, we have three concepts, like we can use a normal table mode, or we can use a traditional index, or we can also use a SuperIndex operations. So like we have three options. One is a normal table mode, and another one is a traditional index, and another one is a SuperIndex, right? So when we say what is index, you can refer the Wikipedia site also. Usually the database index is a data structure that improves the speed of the data retrieval operations on a database table at the cost of additional writes and storage space to maintain the index data structure. Indexes are used to quickly locate data without having to search every row in the database table, right? So indexes can be created using one or more columns of the database table. That is the usual index, right? When we come to super index, see, in our super index DB, we have index. Please note that we are not omitting the index. We have index. You can use a traditional index. You can use the traditional way how the operations will be there. Apart from that, if I mean, you can also have option to use a super index DB, super index data structure. Like super index is a data structure that improves the speed of the data retrieval. The O of n is one. In the previous video, you can see there is one video I have posted, like how SuperIndex DB is different from other traditional or RDBMS databases. That particular video you can verify it for more information. Or here also, right? Here also, see, I just added it and I'll just go through it like one by one. Like the syntax of SuperIndex, right? You can just create a SuperIndex on any table name with column name, and you can drop the SuperIndex. That's a concept. These are the two syntax with the two statements what we have. Okay, this is a sample Java program. As I already mentioned, you can connect it to the database, SuperIndex database. You know, after that you can create a table. You can insert a record. You can do any operations you want to do it. Okay, we'll see some sample Java code, right? For create table, see this is a table name, COVID-19 patient. So that's a table, just we are creating it for our demo application. But anyway, I'm just showing it. So COVID-19 patient, patient name, age, table is created. when we execute the statement. And when you go to the insert, yes, insert into the table, whatever the column names you specified, I just specify the name, see my money is age is 40, and just enter the record. The record is inserted. The similar way, update the record. Suppose you need to update the record. See, just think about it like SSN in United States or Aadhaar in India, right? If somebody want to create another number or SSN number, it's an insert. If somebody want to change the address, that's update, right? So we need to update the records, right? So that's a update, update the table, set ages for 39, where patient name is money. Only for money, change the age is 39. That's a way. That's a update record. Select query. Sometimes, many times we'll be fetching the record, right? So how we will be fetching the record? Like select star from the table name, just specify the query, and you will get the records, right? You will be, I mean, execute the statement, you will get the records. That is select. Sometimes you need to delete the record. See, Aadhaar number. I want to delete it from the Aadhaar table because a person is died. So I don't want to maintain his other records if I know that details, right? So we can delete the COVID-19 patient that, or any table name where the patient name is John or something like that. Record deleted, you know. So this is the basic operations of the database. Okay, coming to SuperIndex DB, right? Special, right? As I said already, there is a concept called index that is there still with SuperIndex DB database. We also have the concept of SuperIndex database. I mean SuperIndex data structure. See, like somebody is selecting the table where age is 40. Actually, we don't know like how many number of records are there in the table, or how many number of operations happening, or what is the data types we have, what is the data type complexity. It depends upon all these. The response time matters, but this is the example we are giving for a particular table. Say for example, this is taking 10 seconds to retrieve it. Oh, so if you create an index, right? If I create an index, okay, in a table, I'm seeing that the response time has come to 2 seconds. That's the concept of index. I'm going to talk about that more, even in my previous video. That is how SuperIndex DB is different from others. I just mentioned how the index is happening. So if you delete the index, whatever the index you created, if you create a super index instead of index, if you create a super index, and if you do the same operation, same select operation, here you see the difference. Normal is 10 seconds and the index is 2 seconds, but super index is 0.5 seconds. But here the table count is not important for the response time for us. That is SuperIndex DB. So for us, it's a any even trillion record, 1 trillion record, 1 million record, 10 million records. SuperIndex DB is going to give you the same response time because of our data structure, SuperIndex DB data structure, that we can talk more here in the later part of this video, or in the existing videos you can just refer, right? So this is the sample Java code, how the that is connected to SuperIndex DB. Okay, uh, I want to talk here. No, usually the database, this is a animation just for your quick understanding. Usually the database, it has a relations, and it is connected in a relational way. Say employee ID is connected to the employee name, and the employee name is connected to address, and the joining date and everything, right? So the same thing when you come to other table, that can have a relationship, between the first table and second table. The salary table, the employee ID and the salary, it can connect to the other tables. There is some relations. See, this is one particular table. Just you see, there are a lot of records, rows, right? Other, for example, other number, other number. There are a lot of other numbers. If it is SSN number in United States, there are many SSN numbers, right? The records will be there, right? So imagine these are the records in the table, and I want to do a search. I want to search one particular Aadhaar ID in a Indian Aadhaar table, or if I want to search one SSN number in SSN table. So what I will be doing it? Obviously, you need to go one by one and check whether this number is this, whether this number is this. That's a linear search, right? That's a sequential search, correct? So what will happen? Say, for example, I want to search one other number with the first record. I'm searching. Oops, that record is not matching. Then again, I'm searching second. No, it's not matching. Again, third, fourth, fifth, sixth, it's not matching. So in one particular point, it will match. It will say, yes, the record is matched. But what happened? It's a big task for me. It's a table scan. I'm wasting my time with searching other records. I spent a lot of time, a lot of energy, a lot of computer resources, CPU utilization, memory utilization, disk utilization, right? So it's obviously right. So what's happening? Okay, in this particular combination, one particular example combination, it takes 10 seconds. Just imagine. That's a one table combination. We don't know. Like, see, the response time is completely depends upon the number of records in your table and the data type of the table and the relationship of the table. There are many things and the way how you are querying. But here, this particular example, I'm just giving it's a 10 seconds, right? Okay. Why this response time issues are happening? As I mentioned several times, it's a sequential search. Okay, do we have any solution for that? Yes. Industry in a traditional RDBMS databases, RDBMS connections in the databases, they have a solution. The industry pioneers and industry research people, they have already have a concept called index. Index, it is in this traditional solution, right? So we have a B tree data structure, binary tree data structure. There are some tree data structures which is avoiding the number of search table scan. You know, see, I want to search, for example, I want to search the salary. I want to search a person with a salary of rupees 6,000. So if the person is having 6,000 rupees salary, I don't want to search with everybody's salary, right? So I can divide the total salary of the company. Say, for example, the minimum salary of the company is 1,000 rupees or dollars, or 100,000 rupees or dollars. There's a maximum. So in between that minimum salary and maximum salary, only this 6,000 will fit, right? So I can divide the total number of records into two parts, saying that, below 50,000 salary or above 50,000 salary. It's a tree structure. So trees have branches. And, each branch has a child branch. There is a subsequent branches, right? The similar way. So I divide it. Under 50,000 category also I can divide again two times. 25,000, 25,000. Again 25,000 I will do 12,500, 12,500. So that keep goes, right? So this is the trees. You see that one has two childs, 2 and 3. Two has three childs, 4 and 5. 3 has two childs, 6 and 7. That keep goes. So when we divide like this, right? So I will eliminate the number of table scans into 50, 50, 50, 50%, so that the search operation will be very fast. This is one example of index. This is not only the right example. Indexing has a index keys, right? The postal example, right? You take a postcard, we will be keeping it in the postal cover and keep it in the postal office, right? If you want to know the postal cover, you can just take the post cover and see the index key, based on the index key. Okay, row number 678, there is a column 678. There only I kept. Say, for example, in your home, if you have one particular spoon, right? I need to go to the kitchen, and in the kitchen, in the rack number 2, and in that rack number 2, column number 4, and exactly in between this one and that one, the spoon will be found, right? So that particular key, the key stuff that you are storing in your mind. The similar way, they are indexing. Sometimes it keeps the index key, and the people will be using an index key, and they will go there and they will use it. So here, so that's a concept. So okay, practically, if you want to know like how indexing is improving the response time, I'll show you. Like, see, as per our example, the records, right, it will be in a tree structure, right? It will be like this. Okay, so when the data structure is like this, what happens? I want to search the same record. Before creating an index, we searched and we took 10 seconds for our combination. So now we are going to search again. Okay, the first record, oops, I don't have it. It's not matching. That record is not matching with the search record, what I'm trying to search, right? So I'm just doing a second search, I'm doing a third search, and just keep going it. And finally, I got it. Somewhere I got it. But compared with the previous response time behavior, this response time behavior is far better. You know, yes, that one took 10 seconds, and this one is taking only 2 seconds. It reduces the time and effort. The same table combination, you see that same table combination, it just reduces it, right? So this is the improvement with using indexing concept. Are we happy? If you ask industry, yes, they say yes, but it's not good, right? Still, it's searching, 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 and if the records are huge, say 100,000, 1 million, 1 trillion, 10 trillion, 10 billion, just if you keep grows, right, the number of records, what will happen? Still we see the linear growth, and the response times will grow, in a way. So that's what is happening. So to overcome that, the industry has come up with no SQL concept. That's a new concept. I'm not comfortable with that concept. See, what is that concept? See, one other number person will come X and Y Z day, and we need to keep his search results now only in a view. Whenever you come and fetch it. I will give you. No, that is not a real time operation, right? Search operation, real time operations, right? So most of the time you need a real time operation. Say for example, lot of SSNs, right? In United States, here in India, we say a lot of other numbers, right? When we want to do a real search, we need to do a real search. So this is not going to be the solution. Indexing is not going to give you a solution. So SuperIndex DB, right? We have found a solution. So we have innovated a new data structure. That data structure name is called SuperIndex. What does this SuperIndex does? Simple. It improves the response time. Whatever the number of records, right? 1 trillion, 1 million, whatever the records you have in a table, it exactly maintains the same response time when 100 records were there. It just directly go to the database exactly to the location and fetches the information without matching with others. Without matching with others, without matching other records, without doing a table scan. Okay, that is the data structure, working procedure, right? It just goes directly into the record without scanning others. Okay, okay, just take our example. Right? The records are sitting in this way. There is a relation. Now we want to search the similar way how we searched earlier without an index or with index. Here in the super index, we do the search. Here we are not mapping with anybody, or we are not scanning it. Directly we go to the record and we fetch it. That's the concept of SuperIndex DB data structure. Okay, yes, it's great. Wow, the results are good. See, it took only 0.5 seconds. The same table combination, whatever we saw earlier, 10 seconds, and again with index 2 seconds. Here it's 0.5 seconds. Whenever the total number, whatever the total number of records are, it doesn't care. The response time is same. Please note that the response time is same. Okay, overall, what is SuperIndex DB? It solves, um, all the database issues in the industry. Please note that we have all the existing features or DBMS features. SuperIndex DB serves all the old or DBMS features. At the same time, we are also having a NoSQL features. We are serving all the old NoSQL features, the views or everything. Plus, we have a new innovated SuperIndex data structure that solves the response time issues from the existing databases, especially when the records in a table are huge, massive. You can call anything. SuperIndex option is available on the top of the database features. Okay, if you want to elaborate the response behavior, as I said, the O of n is not 1, it's almost 1. It means that, yes, it's not big difference. Say 1 million records in this example, right? The traditional response times you see 5 seconds, 10 million records in 7 seconds, 1 billion records in 12 seconds, and 10 billion records in 16 seconds. SuperIndex DB also has the without index without SuperIndex concept, but it maintains a similar industry response behavior. But if you go to RDBMS databases with indexes, right, it reduces from 5 seconds to 2 seconds, and 7 seconds to 4 seconds, 12 seconds to 6 seconds, and 16 seconds to 8 seconds. The similar way, the SuperIndex DB also with indexes, it maintains the same similar response time. This is one particular example. See, don't compare with your whatever the response time you have. That is all. There are many factors are there. Number of records, data types, the data vary because the address is big, and the employee ID is small, and credit card number is 16. So it depends. So don't worry about it. But for this particular example, SuperIndex DB with SuperIndex option, when you put it, it just has 0.56, 0.6, 0.7. It's very less response times, and it also maintains whatever the number of records are. Yep, it's a picture-based comparison. See, O of n is almost 1 with SuperIndex DB. Yes, traditional RDBMS is without indexes, it goes very high response time behavior. With traditional RDBMS with indexes, it just maintains different. And SuperIndex DB, also maintains the same. But when we have SuperIndex option, the response time is flat. Okay, you may have many questions like what we have discussed. See, this is the basic database server concepts, right? So I'm planning to put more videos related to Java, J2EE, .NET, database, SuperIndex DB features, and so many. So you can watch our videos. If you have any further questions or anything in your mind, right? Just you can contact us. We have three mediums to contact, right? One is our mobile number. It's an Indian number. It's +91 98456 89152. Our email address is contact us at the rate superindexdb.com. Our website is https://www.superindexdb.com. And after launching to the web page, another website, you have many mediums to contact us. One is the contact us page, and another one is support page, and you have training support page. So you can just ping us. Okay. Hope this video is helpful to you. You would understood what is SuperIndex DB is, what is database server is, and what are all the database server concepts. If you like it, please like the video, share it, comment the video, subscribe us, and it will be useful. And we will be posting many videos related to database server and SuperIndex DB concepts and everything. Okay, thank you. Have a nice day. Thank you. Bye.